Welcome to discuss number 6, where we are going to talk about pioneering design at NASA. So talking about reflections on the human-centered approach with our distinguished speakers. So let me introduce you to DISC. I'll just briefly start introducing you to who are we, designers in space community. We are a community of advocating for the strategic use of design within the space sector, and we believe that design is much more than just aesthetics, is a strategic tool for shaping how missions and services work for people, especially in the space sector. And we promote this user-centered, especially collaborative and design-driven approaches to help create space solutions, space products, missions, to help to have this real impact on users and the planet. That goes much more beyond the technical requirements. All of us are very much aware that the space sector is changing, and we see design and a human-centered approach as gaining momentum and becoming an increasingly important part in this transformation. So as a community, we bring various creative profiles and space professionals together who obviously share interest in space and believe in a strategic role of design. And what we do, basically have a lot of expertise on this topic within our community. So if you're thinking about bringing more human-centered approach and collaborative approaches to your organizations, feel free to reach out to us. If you are looking also for designers, perhaps, to join your team or collaborating with any design company, please, or if you have any related job openings, please feel free to reach out as well. We might be able to help you connect with the right profiles within our community, which is growing. So that's very exciting as well. We, of course, organize events like this one online and also in person at the major space events and design conferences as well. We want to create this value and conversation and learn from each other. And creating these inspirational moments. And of course, we also do some courses, education at the universities and companies specifically focused on user-centered design methodology, design thinking, specifically tailored for the space industry and using the real case studies as well. So if you want to know more, please follow us. We have a bunch of articles on Medium from our members, some case studies, examples of how people got into the industry, some stories from our community. So that's a great resource to look at. We have recordings from the past events on our YouTube, so please follow us on YouTube and on Instagram, where you can find a summary of other events. And yeah, if you wanna get involved, we have a membership form, which is free. You can join DISC for free and just fill in a short membership form, and you'll also get access to that form or directly through the link to the WhatsApp group, where we have a little forum and we are sharing insights and articles and many other things on an everyday basis. Great. So some housekeeping before we go further. We are going to have 2 presentations from Tibor and from Jay. So let's keep our microphones muted until then. We have a QA section. So if you have any questions during the presentations, please feel free to post your questions there. We'll be moderating that, and we'll have a discussion afterwards, after the presentations moderated by Paul, and there will be opportunity to ask questions then to our speakers as well. And of course, this event is recorded, so hopefully that's okay with everyone. We were planning for this event for a while now, and it was really exciting to meet Tibor and Jay, because both of them have very interesting background. Both of them have formal education in engineering, but also in design, which is a very interesting combination for us as a designers in space community as well. And both of them were championing the human-centered approach in their corresponding teams at NASA. So I'm really looking forward to the discussion afterwards and to your presentations. And now let's start with Tibor.
Thank you very much. Let me just switch over to my presentation. Well, thank you very much for inviting me for giving this presentation for the meeting. And my name is Tibor Balint. I will talk about making space for design at NASA. There are three parts to our presentation: a quick introduction about my background. Then I talk about JPL's Innovation Foundry, which is a concurrent design environment where designers can contribute. It's not the only place where designers contribute, but this is an obvious place, which is a mission formulation part of mission development, and then designers can come and contribute here. And then talk about emerging roles of observers on human space missions and how to create autonomy using boundary objects. So about my background, I grew up in Hungary, and from Hungary, after finishing university, I went to England, got another degree. From there, I moved to Canada and worked in the nuclear industry for about 10 years. And then from there, I always had this desire to get a PhD, so I moved back to England and got another degree in the biomechanical engineering. And once I got the degree, I figured I still want to work in space somehow. What can I do about this? So I went to the International Space University in Strasbourg, and I did a one-year master's program. As part of that, I did my internship at JPL, and I was lucky enough to be hired back at JPL based on my past experience in mechanical, chemical engineering, nuclear engineering. And I was there for, well, I've been there ever since until I retired. But from JPL, I went to NASA headquarters for a few years, and I was a program executive for Game Changing Development, which is the technology development program. And from there, I took a few years off, moved back to England, got another PhD in human-centered design from the Royal College of Art, and came back to JPL as a human-centered designer. So as I was kind of bouncing around with mechanical engineering, chemical engineering, nuclear engineering, all of these experiences contributed to the following roles that I was doing at NASA. And the same way as I was getting my degree in human-centered design, I came back and I tried to infuse that a little bit to the workflow in line with what I was doing. So let me see. Yes, so let's talk about the Innovation Foundry. If you look at NASA, NASA is developing missions, flying missions, getting scientific returns from these missions. And at JPL, we are designing robotic missions. And the way it works is that NASA headquarters is giving us the directions based on the decadal survey recommendations and providing the funding. So the program offices at JPL are getting these instructions, getting the funding from headquarters, and they are funding mission studies, funding missions, funding operations. And the line organization is providing people, the engineers, the scientists, the subject matter experts. And the Innovation Foundry is this environment for mission formulation where we can design future missions and develop them. So eventually we can get funding from NASA. So there are two phases, there are multiple phases, but one of them is the formulation phase when we formulate these missions, and the implementation phase when we are actually flying or developing and flying these missions. So I spent my whole career in the formulation area, and within the Innovation Foundry, I work with all of these teams. So we were developing concepts from concept maturity level one when I had an idea, like a paper napkin idea, up to that point when it was proposed to NASA for funding. So it went through different phases. If you go to the A team, I will talk about all of these phases, but A team is going from concept maturity level 1 to 3. TMX is about CML4, and proposal shop is CML5. So concept maturity level is very similar to the technology readiness level, which is going from tier 1 to 9. CML is going from 1 to 8. So uh, A team is a relatively new team established in 2011 and perform hundreds of studies for JPL. And the design environment when we are designing these missions is called the left field. So there is a facilitator that leads the mission concept studies. There's a diverse team of about 10 to 12 people. Brought in depending on the study that we want to conduct. For example, you can bring in engineers, you can bring in scientists, and focus on those subject matters. If you want to explore a moon, explore a planet, explore Earth or planetary or astrophysics, subject matter experts come in and they talk about science, talk about engineering, talk about all of the aspects that allows us to scope out these future missions. It's kind of blue sky thinking, trade space exploration, looking at initial feasibility. Lots of brainstorming going on using different design tools, building mock-ups. You can see in the background in the picture that you have Lego pieces, kind of building small mock-ups. And these things can be called boundary objects because they're in the boundaries between different disciplines, between engineers and scientists and designers, and sitting around the table, building something. You can use the boundary object as a conversation piece to have a shared language between different disciplines and then also share towards the goals. So this is where human-centered designers can come in. They can participate in these activities. They can help with the conversations. They can help with visualizing these concepts, with either building these mock-ups or maybe having some sketches, having some keystone graphics. And it really helps the team to have this shared experience to develop the mission concepts. So once the team see that, there is something here, there is something worth developing further, then it goes to Team X. Team X is getting more deeply into the concept development. The Team X environment was established in 1995, so it's been around for a long time. It's a mid-concept concept maturity level development environment. It's a concurrent design environment. They completed over 1,500 studies by now. And the environment is called the Project Design Center, PDC. And as a concurrent design environment, all of the subject matter experts work on their own topics, and then they share their findings and then iterate until they converge to a kind of final design. So there's a captain's chair, there are customers, the subject matter experts brought together. The studies last for about a week. Maybe you have 3 or 4 sessions, and they come up with a report that documents a point design about the feasibility of the concepts. So human-centered designers work with subject matter experts to refine the interfaces and workflows. For example, we did a project when we worked with engineers developing different codes for the Team X environment, and then working with customers who are using these tools and making sure that the interfaces were communicating the right information for the users. And then the designers, the engineers can develop the right background information, the background processes, background code, and then communicate through the interface the right information to the users. So once we see that the project itself is making sense, then it can go to the next part when we can say, well, it is at a level when we can actually propose it to NASA for funding. And then it goes to a proposal shop. And this is at concept maturity level 5. And it can go up from discovery class missions to new frontiers class mission to flagship class missions. Different cost caps represent different scopes for these missions. So we completed hundreds and hundreds of proposals, and many of these got funded. Many of these become real flight projects to outer planets, to Mars, all over the solar system, Earth science, and so on. So the teams are led by someone called a principal investigator, who is a scientist, and the capture lead, who is representing the team to develop a winning strategy to win these concepts that we propose to NASA. And we have a proposal manager, who is the chief editor for the proposal that we are working. And this is a document that helps us to communicate the information to the sponsors and to the selection officials who are deciding which missions will be funded. So when designers come in, they are working as visual strategists. They can work with the team itself during the development process, and also towards the packaging phase when we are developing the proposals, and then have the real writing of the proposal so it communicates to the right audience. The language is synchronized between engineers and scientists and the business people and speaks with one voice. We have the graphics, which are developed as keystone graphics. Again, they can be glanceable, communicate to the reader. So it's an art to develop the proposals to the level where people can read it and get the information. It's not a subject matter jargon when you read like an engineering report or the science report, but it's translated to something that the evaluators can read and decide if it's worth something that they want to fund. So the environment is called the war room. When these proposals are being developed, each team is assigned a war room, and within the war room, nobody can access it except the team members. And they are working very hard to kind of have a kind of competition sensitive, closed information that only they know. Because, eventually it costs millions of dollars to develop these proposals, and it can bring in hundreds of millions of dollars if the mission is funded. So therefore, they have to protect their information and then, submit it for evaluation. So this is a mission formulation phase, and this is where people, designers can contribute. Within JPL, there is another group called the studio, and within the studio, it's a small group of people. They call themselves visual strategists, and they are trained communicators. They came from design schools, art schools, and they are embedded into these design teams and also flight projects as well. And they help with visually communicating the information to the public and also help with communications within the team. Let me see. So the activities in the studio, they support the concept shop to develop proposals. They are helping to influence the sponsors. As I mentioned, they develop keystone graphics, mockups, framing of the information, and also help to communicate the information to the public. They can have visual guides, visual presentations, and also help with people who want to present this to the public. So uh, I mentioned about Keystone Graphics. It helps with storytelling, and it's very important because sometimes people don't want to read through hundreds of pages of information. If you have good Keystone Graphics, with one graphic, you can communicate the whole mission concept to a reader very clearly, and clarity is very important when we try to get acceptance for our concepts. So I talked about boundary objects and conversation with boundary objects. So designers can produce, can kind of help facilitate conversations. Each subject matter expert comes with a special language. Engineers speak engineering speech, scientists speak like scientists, and very often they don't understand, or there's a miscommunication between them. Try to figure out, what they actually mean. One example is, there were two groups, and one group talked about operability, other group talked about usability, and they ignored each other's kind of approaches. And eventually, a designer pointed out that you are talking about the same thing. In your discipline, you talk about operability. Other disciplines talk about the other approach, and then they are the same thing. And once they have the shared meaning, like, oh, we talk about the same thing, it is much easier for the team members to communicate with each other. And as I mentioned, the boundary objects, these can help to communicate between the disciplines, because if you have something tangible, something physical, it can be a drawing or a little mock-up or a little prototype. People can sit around and then have a conversation over them, which is very helpful in this kind of evolution of the concept, evolution of the idea, which can evolve. The object itself can evolve through the conversation, the same way as the conversation can evolve throughout the development of the concept. So in conclusion, the Innovation Foundry develops mission concepts for CML 1 to 5, which is the early stages of development. And then once they get the funding, it goes to implementation phase when it becomes a real project. They start cutting metal and eventually develop the mission and start flying it. And within the Innovation Foundry, we have storytelling, keystone graphic, conversations, and that's where human-centered designers can play an important role. And they can bridge the boundaries between the different disciplines with these facilitated conversations. And then again, as I mentioned, boundary objects can be very helpful in this one. And you have this cybernetic circularity as you are conversing with each other and evolving the concept to the next level of understanding. So the Innovation Foundry is a strategic asset within JPL because it helps us to win new mission proposals and funding, and then it becomes real mission afterwards. So this was the first part. And then the second part is the emerging roles of the observer for human missions. While I was working for JPL and doing robotic missions, during my research at the RC, I also looked a little bit into human-centered design for human missions. And the interesting thing was that currently we live in a technology paradigm, and within this paradigm, it's driven by technology, driven by science, and initially there was not much room for human-centered design, but it's gradually changing. It's getting better and better. So currently, if you look at the International Space Station, it's looking like this. It's looking like a laboratory. You're like working in a factory. You work in a factory and you sleep in a factory, and then you get your work done and you go home. If you look at future visions about space exploration or space travel, you can see these movies about having hotels in space and traveling for long duration and just living like a luxury vacation. So it will take a time before we get there, but we have to take steps and start eventually move from a factory living and getting things done to accommodating more for humans during these journeys. So if you look at Maslow's hierarchy of needs, it's kind of the needs are based on each other, and once the level is achieved, then you can go to the next level and eventually build it up to higher and higher level needs. Initially, taking care of the basic physiological and psychological needs, metabolism, using subsystems like environmental control and life support system for air, water, and food. You need power, you need lighting. You work in an extreme environment, you live in an extreme environment. So you want to make sure that your habitat, your spacesuit is supporting your life. And then you go to, once this is fulfilled, then you go to the next level need. You want to have a shelter. You want to protect yourself from the radiation environment. You have to have some system autonomy, some sensors, an alarm that actually warns you if there is something going wrong. You need a communication system, health monitoring. But all of these are still the basic needs. So when we started space flight, we just wanted to show that we can do it. We go to space, get it done, and come back. But as we are getting to space longer and longer, then it becomes important to develop these connections to love and belonging. Develop things like connection with Earth, with the family back, friends back on Earth, also communications between people on in space, on the space station or in long duration space missions. And once that is fulfilled, you can go to the next level. You can have, respect, confidence, time, reflections. If you have fulfilled that way, you can go to the next level, cognitive need and learning and habitat, developing different artifacts and interfaces and growing through experiences. And then, the highest, the transcendence about giving the best for humanity. So, as designers, we can contribute to this by creating content and creating experiences, also to work with autonomy. Because as designers, you can curate these contents and experience and autonomy, and then you can work with astronauts and space travelers who would be using these experiences. And these are not engineering solutions, they are not scientific solutions, they are human centered solutions when interactions are designed, curated for future use. So it's very important to bring in designers once you fulfill the basic needs of Maslow's, and then you go to higher level needs, and then designers can design that. But we have to bring in designers in an early stage because you cannot retrofit an engineering design later on with human-centered design. You can, but maybe not that easily. Maybe you have to get back to the drawing board and start from scratch again. Not like you are designing the car and then you say, oh, you want a wheel as well. Well, in that case, we have to redesign the whole thing. So designers would play an important role for long duration missions where human-centered approaches are benefiting the mission, not only just because it's nice to interact with the environment and with each other, but also it can reduce risk. It can maybe reduce development schedule and development cost if humans and design incorporated early into this system. So designers can contribute to learning, as I mentioned, one of the higher level needs. They can address privacy. You are there for a long duration, but who is providing the environment instead of just floating inside that empty habitat and velcro yourself to the wall, but you have some personal space that you can customize for yourself, and then you feel more safe, secure, more at home, you have more privacy. That's very important. Creativity, you can go up with a guitar, with a, draw something, but designers can come up with experiences, with actions, with interactions, with with activities that caters toward creativity while people on long duration space flight. It can take a couple of years to go to Mars and come back. Most of the time, nothing is happening. You are just cruising. During that time, you have to worry about the psychological well-being of the astronauts. And beside doing their chores, beside training for the mission, by the time they get there, what they should be doing, you also have to worry about, what they should be doing in addition to all of these to entertain themselves. So you have to worry about relaxation as well. The other thing is we have to design for ownership and sharing the physical data, physical information and the data. Who owns that information? What is the privacy of that information? Who is it shared with? So designers can work with engineers and management to make sure that these are addressed properly. So there are many aspects when designers can play important roles for future human-centered missions because every mission is human-centered. Humans are flying, they're experiencing the missions. So designers can create these novel artifacts and experiences that addresses the higher level needs beside the basic psychological and physiological needs. Designers can help to curate autonomy so information doesn't overwhelm the user. If you have an autonomous system, if you have AI on the system, you still have to have interfaces that kind of communicates with the user, and having that interface very clear, that doesn't confuse, doesn't overwhelm the user, it would be very important. So that's why I'm saying you have to curate those experiences. Designers can help to foster conversations between different disciplines, between technical disciplines, between scientists, and so on, even with the technical fields. A propulsion engineer speaks very differently from a software engineer, and making sure that when they design the mission together, that interface is designed in a way that they can communicate, they have the same shared language, so in that case, they don't make mistakes. So it's very important to have a strategic support from management that design can be incorporated into the workflow because in future missions where humans would be interacting with the spacecraft, with the environment, with ground control, these streamlined interactions can have a very important and positive effect on both the participants and the mission outcome. So it's really scratching the surface. I could talk about this for hours, but I only have about 20 minutes and I think my time is up. But I would be happy to address any of the questions that you have. Thank you.
Thank you, Tibor. That was excellent. A lot of insights also about and questions about how can you bring designers earlier in the process as well. So we will hopefully and for sure dive into that discussion in the Q&A part. Now we will continue with Jay's presentation. So Jay Trimble is a former NASA mission manager and senior consultant engineer, and his career spans from mission system design and operations from Earth orbit to deep space. Jay, if you wanna presenting.
Okay, can you see it?
Yep.
Yes.
Okay. Yeah, I kind of feel like Tibor, I could barely scratch the surface. So I'll try and tell a couple of relevant stories and see how that goes. Let's see. That's interesting. Okay. This is just kind of a brief summary of my trajectory. I grew up in the 1960s when we were heading for the moon, and took some inspiration from that. And you can see I was building models and flying rockets. Went to NASA Johnson Space Center in the summer of 1981. That was about 2 months after the first space shuttle had flown. I was a college intern. And then I was a space shuttle mission controller in Houston, then at JPL, where Tibor was for 9 years. Highlights there, the Voyager encounter with Neptune, and then I was the lead operations director for Space Radar Lab. That was international. That was the United States, Germany, and Italy. And then the last NASA job I had was mission manager for the Viper lunar rover. And that is now going to fly in 2027. And you can see the education from geology to computer science to an interaction design certificate. Okay, I want to put NASA in context, right? When we say NASA, NASA is a big place. spread out all across the United States. And so you get the overview there. And again, I was in Houston, Pasadena, and then Silicon Valley at the Ames Research Center. But people tend to say, well, I did this and that at NASA. You probably did this and that at a little slice of NASA. Each center is its own independent operating facility in many ways, and each with its own complex and unique culture. So just to give you the domains that we're going to be talking about here, the first is mission control for human space flight, where of course you've got a mission control center on the ground and you've got a crew up in space. That's been limited to low Earth orbit since 1972. But in the late 60s and early 70s, of course, we were operating in cislunar space and on the moon. I do want to say, there's a cultural complexity and almost sanctity to these mission control centers, right? They function beyond the technical aspect as really almost a cultural temple and touchstone for how we on Earth relate to the missions. And it has a significant impact in how you operate in that environment. Also note, Mercury, Apollo to shuttle, you'll see a technology evolution there, but the layout of the rooms and the functions haven't changed that much. And the Mercury Control Center was mechanical. And then robots, of course, you don't have any people, right? You've got a ground team on Earth doing command and control for a robot, in this case on the moon, but also on Mars and throughout the solar system. So for me, again, I didn't start out with a design background. So I'm just quoting Yogi Berra here, who was a famous New York Yankee and manager. You can observe a lot just by watching, and that for me, so was I just saw what was going on and thought, well, there has to be different ways of doing things. Um, Early mission control, look at the displays and the technology. It was very elegant for its time, right? But it was, by modern standards, pretty brittle and inflexible. Look at that display on the upper left. So, that's a display I built for a satellite repair mission on the Space Shuttle just out of college. It's a very simple grid, really no flexibility at all by modern standards, but it worked. And then the binary plastic overlays we used for status lights and the hard-coded key sets. Honestly, I think those systems, even though by modern standards they're very dated and inflexible, were technically elegant and really brilliant for their time. And I'm kind of in awe of what they did in the 60s. If you look at a modern mission control center, yes, it can do more, but you're buying furniture out of an office furniture catalog. You're getting PCs that are pretty much commodity devices. And they work. They just don't have the elegance. So, the next generation of mission control in Houston, which looked pretty much right, the layouts and operations were similar, but they took those old systems that ran on mainframes, they put them onto workstations. They're running in X windows, those key sets. And let me show you the next slide so we can contrast that, right? Those plastic hard-coded key sets are now touchscreen displays. They're reconfigurable. Honestly, for me, I much prefer the old brittle tactile feedback hard-coded key sets. Even though they were less flexible, they were much more elegant to work with. But my point here is we are evolving technology, but not really changing fundamentally our approach to operations. I do want to emphasize it's a system engineering culture at NASA. You can nibble around the edges. In my case, you can form a design group. As a mission manager on the Viper mission, I had designers involved. But the fundamental culture at NASA is still a requirements-based waterfall, system engineering, hardware focused. And for the large projects, right, you're talking contractor performance based. All of these things are fundamental game changers. If you want to insert design in a meaningful way, you have to understand not only the technology approach here, but the culture. So for me, I'm like, okay, there's got to be a better way than what we're doing. And this came to a head for me at JPL in my first mission operations manager job, where we did software in the traditional requirements-based way. We had our stakeholders sign off on those requirements. We went away, we built that software, and they came back and they said, "What is this?" And I'm like, "Well, you signed off on this requirements document." And clearly, this waterfall approach just had its problems. Um, so, that was what inspired me to go down a path of at least learning about design because there had to be a better way, right? So I moved to Silicon Valley, Ames Research Center. And there, there's a little bit more flexibility. It's not a mission center. It's a center that has missions, but missions are not its primary focus. And that left a little bit more room in this case to innovate. Now, I would argue JPL is also extremely innovative, right? But at JPL, you are working for Caltech, not NASA, and it's fundamentally a different culture in large part because of that. So I went to Ames. There was an opportunity to work with JPL on the Mars rover. So I said, hey, let's do this human-centered computing program. We proposed that to JPL. It was really inspired by Don Norman's book, The Invisible Computer. Interestingly, we didn't propose tools. We proposed methods. We said we're going to go with ethnographers and we are going to watch what you're doing. And from there, we're going to propose solutions. So we didn't try and throw anything in their face. We didn't try and say, hey, we know how to do this better. And JPL was just great to work with. They were really open, and I thought we had a great team arrangement there. So this is just a brief blip. In a field test on the left, you'll see one of the science team members, right? And he's just using flip charts. Okay, well, IBM Almaden Research Center was developing this big touchscreen board called Blue Board. So we worked with them and developed what we called the MER board, Mars Exploration Rover Board. It had a number of applications. On the bottom right, you see something called Saltree tool. And for the first couple of months of the Mars rover mission, they used that Saltree tool to do their long-term strategic planning. I think what's interesting about this is, again, we didn't come in with some idea of what we're going to do. We just watched, looked for opportunities, and then worked with JPL to implement things. And the results were mixed. We had some great successes like the Saltree tool. And then we had instances where the tools didn't get a lot of use. It was mixed, and it was a really interesting learning experience. But I feel like we got a lot out of that, both in terms of knowledge, the tools we developed and the relationships we developed at JPL. So I'm going to skip over this in the interest of time. I do want to note that at the time, right, before the iPhone, I think it's, remember what design played in the I was going to say, the international psyche before the iPhone. I think before the iPhone, people thought design was making it look cool, right? It was about aesthetics. I think the idea that design had the kind of value that we think it has was a niche way of thought before the iPhone. And maybe I'm exaggerating here, but I will say from my standpoint, post iPhone, the idea of proposing design anywhere, at least anywhere that I was involved, changed significantly. People were open to it and actively interested, even though they didn't necessarily know what it was. Okay, so a few lessons here in the space community, right? It's small. If you're going to go in and work on a Mars rover mission, everybody knows everybody. You got to speak their language. In my experience, it's very few stakeholders really care about design. They don't. They care about results. If design is going to get them results, great. And then I'm quoting Howard Aiken at IBM. Maybe this quote is applicable to large organizations, right, that have a lot of inertia. But if your idea is already good, don't worry. You're going to really have to work hard to get them implemented. So I think also, if where we tried to go against any established convention or mental model, in those cases that didn't work, and God, don't try and take away someone's existing tools. Give them something new. Let them get used to it. If you propose replacing something, you're going to get a tremendous amount of resistance. And you may be incredibly excited about your cool new technology, but a lot of these guys, understandably, these folks, they just want to get their jobs done. And you'll find a few people who are excited about new technology, but in my experience, that's going to be the minority. So, the human-centered computing for the Mars rovers, right? That was about tools and methods. And at this point, I didn't really want to be going to other groups and saying, "Hey, here's something we think you should do," or working with them to try and do that. We wanted to build our own tools. We thought that would give us a lot more flexibility in what we could design and build. So I was able to form a group at NASA Ames called the User-Centered Technology Group. We pioneered in our corner of NASA agile user-centered design, and we did spread that to some other parts of NASA. We worked a lot with our colleagues in Houston on that, and also with JPL, though of course JPL was taking their own path to innovation, and they were doing a great job. So another group at Ames, the Applied HCI group, right? They continued to provide services, and I think they worked very closely with JPL, and I think JPL liked what they saw to the point that they started their own capability in Applied HCI. And I think for a group of HCI evangelists, that was considered a great success, right? Spreading these methods into more parts of NASA. All right, so I'm just going to briefly, in the time that I have left, talk about one of the technologies we developed. And it's called Open Mission Control Technologies, OpenMCT. I will say here, we've got use all over the world for this tool. I would like to think that's because it's brilliantly designed, but the reality is it's as much because it's open source as anything. And being open source, of course, allows users to take ownership, build their own version, do what they want with it. And that's a great enabler for getting people to use their tools. Okay, so the key here, and if I were you looking at this, I'd say this looks unremarkable, right? You've got a directory tree on the left, you've got the content, of course, in the middle, and then you've got an inspector. But behind the scenes here, you are integrating data from what used to be many different sources all into one to display them in that tree. You're also integrating historical data with real-time data, which was new. And then in the middle there, we're giving people a space. Let me show you this on the next slide, where they can compose their own. So what used to take months, literally can now take minutes, right? In my day, we used to have to go to a separate group and spec what we wanted, and they would build it for us, right? Then X Windows again, and a little newer, but here we're taking all these different areas that used to be siloed. We are integrating them. You press that create button, you've got a composition space. You can build very complex capabilities without any programming, and you can do it very quickly. So, one example, and you can see the progression here, that paper display I love to show, and then the heterogeneous siloed environments that came next, and then again, the ability to do these very complex displays and do them all in one place. I want to, well, okay, you know what? We'll get to that in the next one. Okay, so some examples. Uh, Here's some of my notes. Admittedly, this is the 1980s, okay? But if you actually looked at what was happening when we did Open Mission Control Technologies, when you are on shift for a human spaceflight mission, you are taking notes, you're putting your mission elapsed time in, or your UTC, and you're taking notes on what's happening. That's a fairly labor-intensive process. Last I saw, that was not on paper. It was being done in Microsoft Word. We put it into our integrated environment. The difference being, the time tags are automatic and all the data is integrated. So now instead of having to reference separate data, you can link it, screenshot it, and create an integrated data space and a note space. And that for a mission controller who's trying to do this in real time is a huge advantage. In fact, JPL even adopted this as part of their multi-mission software system. Okay, I want to highlight another example of where we took core idea from the 60s, from Apollo, these binary display overlays. Okay, we've got status lights. And it's the same idea, but those status lights have complex logic The logic behind these requires no programming, right? You can do this all within the OpenMCT environment, and then you can compose it and mix and match in your display however you want. Again, I'm very enthusiastic about OpenMCT, and I could talk forever, but I won't. So some of the use we got out of this, of course, we use it at Ames, and it will be a big part of the Mission Control Center for the Viper lunar rover. At JPL, we have more users at JPL than any place else. I think there were 12 to 15 missions at JPL using this, and the Advanced Multi-Mission Operations System, which is NASA's Science Mission Directorate multi-mission system, standardized on this, and that's managed out of JPL, Goddard, Houston, Houston Research Organization, not Houston Mission Control, other NASA centers, um, industry, defense, university, people all across the world. A little frustrating to me within NASA. There's a lot of limitations to what we can and can't do in terms of open source and branding. So the reality is, um, the only way we know who's using it is when people reach out to us or when we Google it and see what people are doing with it. So I'd love to know more about our user base. And that's really it. I'm going to do this last slide. This was for fun. We tried to take something from 2001, A Space Odyssey, and then do something similar in OpenMCT. And I think I will stop there and leave it open for questions.
Thank you very much. That was super interesting. And I think we all appreciate the open source character of the MCT. I think it's very, very interesting. Okay, let's move to the discussion part, which will be moderated by Paul Topf, who has worked as a user-centered design specialist for ESA Exploration Preparation Group and NASA's Center for Design and Space Architecture, supporting programs such as Gateway, Argonaut, and Pressurized Rover, and of course is also a DISC member. So yeah, Paul, please, the floor is yours, and all the panelists as well, of course.
Thank you very much, and thank you, Tibor and Jay, also for those presentations. Super interesting to see that overview and to see that incredible amount of experience and practical experience that you've had working within NASA. Starting off, I'm very curious because you've both, I think, really shown how you've really been able to work and champion design methods within your organizations, and that there's really been a growth in the adoption and the understanding of it, as you said, Jay, also with iPhone really helping us spread that story and make people understand what is the difference between a process where designers were involved and a process where they maybe weren't involved. I'm curious, maybe to start with you, Tibor, what do you believe are currently some of the main barriers for further widespread adoption? And what do you think, do you think there is space for further adoption of design methods?
Well, excellent question. There are a couple of things that I could bring up. One of them is kind of providing leadership in design. And the other one is appropriate funding. When I was starting at JPL and the new funding came in and there was a funding cut, the first thing was going is technology development. Now, technology development a little bit more stable, but still getting cuts. But designers are the next round because it's emerging field and people growing up in a kind of living in a technology driven paradigm, they don't really see how is crucial to be part of the activity. We can just bring back designers when we need them, and then so it's a back and forth kind of activity. You can have a bottom-up and top-down approach. Top-down approach when you have a manager, head of a center and said, we want to have designers on the team. So in that case, there's a requirement for that. And let's make sure that we allocate funding for this. And the other one is the bottom-up approach when you say, okay, let's just try to find where designers can contribute and then have enough examples that demonstrates to management that designer can play an important role. In that case, once they see the light, then they will allocate funding and allocate the resources and then provide it. The barrier is the middle management because middle management based on requirements. If there are no requirements, they don't care. So if you are an early career person, you start out, you want to introduce something designer internally and go to your middle manager, the answer is like, it's not my requirement. So why do I spend resources on that? And if it fails, it's my problem. So go away. Then you can start to go around the middle management and they say, okay, let's go to top management because they want to hear about good ideas. And you get fired because the middle manager will be upset saying, why did you go over my head? So you have to have top management who is trained in this and they understand the value of design. In that case, they can come back and say, yes, you have to have a requirement for that. Here is some money for it. In that case, middle management is very happy to adopt it because
Mm.
suddenly it's part of their job.
Yeah, that's interesting. I think that fight and that struggle, that sounds very familiar to me as well. In your experience, have there been certain sort of main benefits of including designers that you've experienced were very successful if you highlight those? And maybe I can throw that one to Jay.
Actually, I do want to comment on the other one. If you're going to get design into a system engineering culture, you have to understand that system engineering workflow very well. And you have to understand where people feel like this is a luxury versus a necessity, right? So if you've got something that is perceived as a nice to have, it's always going to be the first thing to go in tough times. And then on Viper, again, I was mission manager on Viper. I never said, well, I need a budget for design. I just had a budget to do the job, and I could allocate that budget right according to the way I thought best. And then there I was able to incorporate designers. But I think, if you go back to again the Maslow's hierarchy of needs, right? When you are feeling threatened, you're gonna go into those most base level needs. And as long as design is considered a luxury, I think it's always going to be at risk. It's how can you say, design is a necessity, and that's a longer conversation. And to be honest, I don't know if design is a necessity, though I think it can greatly enhance what you're doing. Sorry, I didn't mean to.
Oh,
So,
that's very
so I'm
interesting.
sorry. What was the other question you asked?
Well, in your experience, what have been some of the main benefits of designers that really sell it to say this is a capability that we should have on the team or in this program?
So when you've got any software in which humans are involved, right? And a lot of software, especially the flight software, right? There's no people directly interacting with a lot of that functionality. If you're doing clock sync on board a vehicle, you can do that to requirements. When you have people involved and you're operating a vehicle, system engineering requirements-based approach is really a flawed approach, right? That approach is designed for hardware. And you can clearly illustrate the benefits of design. It saves money not only in development, but you will get a working product. You will get a more effective system. You'll get a safer system. And you can absolutely speak the language of the stakeholders and illustrate the value of design. So I am a big believer that, a hardware-based system engineering approach is a very obsolete way of building software for mission systems where there are human interactions, and a agile design-based approach is much more effective. And that sort of thing should absolutely be able to survive and even thrive in a cost-cutting environment.
Hmm, interesting. Tibor, I know that you've hopped the pond a couple of times and you've done research also in the UK. I'm curious from your perspective, have you noticed, and Jay talked a lot about culture and how important that is, right? So have you noticed in your experiences between Europe and the US, can you point out, are there any differences in culture or understanding of the role of design there that one should be aware of when you're working across the two regions?
I think the culture is very similar on both sides. They are both, space exploration related, technology-driven paradigms grew out from early stages of space exploration, and design is a new field that tries to break into this and tries to demonstrate that actually there's a kind of a demonstrable benefit to include it. And this is an uphill battle. And I want to circle back to the 1800s when they reformed the English educational system, and they said the important thing is the three R's: reading, writing, and arithmetics. So in that case, there's not even R. So writing is not R. But the bottom line is when people grew up in that educational system, design and art was not represented. So when people have management positions who are not informed about art and design, they don't see how it fits into the paradigm. So it's like we have to broaden the paradigm, include art and design, and somehow we have to demonstrate to them that actually it's a worthwhile exercise.
Right. Okay. In your presentation, Tibor, you mentioned some different roles for designers, right? You talked about concept design, facilitation, visual communications, and also the role of the human observer that you see as an emerging role very much. Um, I'm curious, Jay, whether are these roles that you've worked with as well in your design teams, or are there other roles that were not mentioned in that, or yeah, how is that represented in your teams?
Well, so for me, right, my career has been missions that are already, right, allocated, right? So we then design that mission, right? We design the system to meet those goals, right? And then we build the vehicle, we build the mission system, and we fly the missions. So, I wasn't involved in those early kind of brainstorming conceptual uh, spaces, right? It's been more plan, train, fly, build the vehicle, fly. I will say something fundamental here is whether you're doing something in-house or whether you are doing it through a contractor. If you're doing, a large rocket, you're building an Orion space capsule, for example, right? Those things are going to be done through contractors. A rover, a moon rover, right? That can be built in-house. A Mars rover makes a fundamental difference in how you approach things.
Right. So, what were the roles that you had in your teams then? I imagine UI, UX roles, or what kind of roles did you have?
For designers, yeah, they
Mm.
were they were UI UX roles.
Okay.
But again, they were deeper than that, right? The designers were really fundamentally involved in the process design for the mission systems.
Mm.
And then, of course, at JPL example and others, we had ethnographers where we would go and observe, right, and try and understand the processes, the pain points, um, and again, how to work with, the culture, because that's a big part of whether you succeed or not.
I see there's a question from Alicia. I hope I'm pronouncing that correctly for you as well, Jay. What would you change or enhance in MCT?
What would I change or enhance in OpenMCT? I'll tell you what comes to mind there. We started with telemetry, and people still perceive OpenMCT as a telemetry application in many cases, where it is this broad, multi-domain space. Uh, if I could, and now that I'm outside of NASA, maybe I can, I would like to put more effort into the community, the open source relations, and it focus on understanding what the product can do, not just putting it out there, but really understanding what it is and how it can be used, and what that vision is, and open and working with the community in that way. If I could add a feature or an enhancement, I'd like to work with notifications. I think notifications, right? We all have notifications, and we know how burdensome they can be and what you have to do to filter out what you want to get right. And it's the same in space flight, right? I'd love a notification system where I could be notified of the status of my mission in a meaningful way that didn't include the types of things that make me ignore all the rest of the notifications. If I could work on one thing right now, it would be that aspect.
Thank you. Danica also has a question. Maybe Tibor can answer this one. Do you have an example of maybe one big battle that you fought and that you won and that you're maybe especially proud of in your career?
Well, it's a bit of a kind of a silly example, but one big battle was during proposal development. It was very typical that everybody's using Microsoft Word. And I was fighting for my team because I was a capturalist, so I could control the whole workflow. We introduced InDesign, and we worked through the whole thing. Everyone was pushing back, management was pushing back, team members were pushing back, but eventually it worked out quite well, and our proposal turned out very nice. We brought in strategic editors, we brought in graphic designers, and worked in InDesign. And until the very last moment, we could edit the document and then submit it while other people were struggling with Word and crashing on them. So that was very nice, and I don't know if they're still maintaining the same approach or not. They reversed back to Microsoft Word, but while I was there, my teams always used InDesign. It's a small battle, a small win, but I was very proud of it.
Thank you very much. Jay, you said that it's important not to throw design in people's faces and say that you know better how to do things, right? So I'm curious whether you have maybe a trick up your sleeve or a way to break the ice when you notice you're going up against someone who maybe doesn't understand the value of using design methods, or maybe someone who doesn't really know what it represents. Have you had a trick up your sleeve to break the ice with stakeholders like that?
We use participatory design very effectively, where in effect we guided design sessions, but we brought the domain experts in, and then they became part of the team. And I think that was the most effective thing that we were able to do. Take those folks, make them part of the team. They know their job better than anybody. We guided and facilitated the design sessions, and I think they came to very much value that participation, as did we.
That's
Uh,
very
I,
interesting.
I,
Well, sorry, go ahead.
I like to also bring up other example. At JPL, different designers came to work there, and there were some designers who had an approach, a kind of a mentality saying, "I'm a pure designer. I know what design is, and I will tell people what to do." They didn't last very long. But there are other people who say, "I'm a designer. I have my background, but I try to learn about your field, about engineering, about science, and then add design to it and see how I can help you, how I can complement your work." Those people actually were very successful.
Nice. I like that a lot. You've both mentioned sort of the role of the facilitator. I'm very curious because you've also mentioned that systems engineering is sort of the rule of the land at NASA. So,
Absolutely.
what are your thoughts on the role of the facilitator versus the role of the systems engineer or the systems integrator? What are the key differences there that where you go and you say, hey, these are actually two separate things, and we do need a design facilitator in addition to a systems engineer?
Well, so system engineering, right, is a whole set of process for how to specify, right, a design and the interfaces and all the touch points and all the things that the different organizations do. And it's typically requirements based, right? And then you have verification and validation. Verification is, did I meet my requirements? Validation is, did I solve my problem? A designer might say, well, the right design, right, versus getting the design right. Um, but these things fit together, and I think the key is that you fit them together. I would never go in and say, okay, I've got a designer, I don't need to do system engineering. You're absolutely doing system engineering. You're just integrating design into the system engineering process. In the same way that if you're doing agile, right, you're still doing gate reviews, and you can preserve elements of the waterfall that are key elements, but you can integrate agile into those things. So I don't know if I'm answering your question. I don't see it as an either or. I see it as how you put these things together effectively, tailored to the domain and the project that you are working on, because each one is different.
Hmm.
So the way I see it is if I bring up Paul Pangaro's co-evolutionary design kind of approach, we have to have conversations. It's kind of a cybernetics-based interactions. We have to have a conversation about the goals that we want to achieve. We have to have a conversation about the means how we want to achieve it. We have a conversation about designing the designing. So if the current processes are not valid, then we have to come up with new designs and for the environment, and also a conversation about their language. So we have to have a shared meaning, and facilitators help with these conversations. Systems engineers can help with tracking the requirements and make sure that everything is answered, but facilitators go beyond that and helping with the conversations.
I
Thank you.
don't I don't disagree with that. I will just say that the larger the NASA project, I mean, the system engineering culture is beyond challenging and for good reason, right? That's how we do engineering.
Yep.
Maybe both of you can also just use just a minute to provide some insight. I'm seeing a couple of questions about resources and inspirations as well in terms of design methodologies. So I'm curious whether you could highlight a couple of maybe other designers or methodologies that have been an inspiration to you in your work. You already mentioned Don Norman, Jay. And then if there's maybe also some resources specifically where you maybe can go for good graphics or for good tools that you've been able to use in your work.
So that was, I was going to say, go ahead.
No, go ahead. You start.
There was one question about how NASA JPL introduced design. Well, the way I see it is, or that influenced me, is Scott Davidoff. Scott Davidoff was working at JPL, and he was the one who started hiring designers and then try to embed them into design team, convincing mission managers to include the designers he hired into their projects. So it was a bottom-up approach to have enough demonstration of small wins that showed management that actually we can do this. Initially, when he started hiring designers, they were not even a category for designers at JPL. So they hired them as engineers, and secretly they were working designerly jobs. And so that's for how it started at JPL. And then his group started to grow, and the group split. Now the group merged back together because after the layoffs, actually the group shrunk quite a bit, and then there was no room for two design groups. But it's kind of hopefully it will turn around and hopefully it will grow again. And influences, well, I like to mention Raymond Loewy, who was very influential in human-centered design and designing kind of insides of space habitats. And then from not a space-related field, Ronald Glanville, who is a cybernetician, who was my PhD advisor at the Royal College of Art. He introduced me to cybernetics, and that was very influential for me to try to kind of frame the whole environment differently. I came from engineering background, engineering environment. I was thinking about the whole situation through that paradigm, and introducing with this different perspective, cybernetic perspective, was very helpful.
So interestingly, when I was at JPL, I reached out to NASA Ames because they had a human factors group. It was called Human Factors at the time. As part of the Mars Exploration Rover Human-Centered Computing project that I had mentioned, right, the Applied HCI group at Ames did some work with, I believe, Jeff Norris. That is what led to Scott Davidoff and that founding. That was all seeded by that work we did on Mars Exploration Rover Human-Centered Computing, and again, the Applied HCI group. So it's interesting how that spread that way. For me, it was definitely Don Norman, the design of everyday things, the invisible computer, Terry Winograd bringing design to software, those sorts of things. And then, of course, Scott Klemmer at UC San Diego and those interaction design courses was greatly inspirational to me.
There was another question about resources. When resources are low, what can we do about this? How to get management buy-in for that? Well, it's not an easy situation. One way to do it is, start working with the system and having guidelines for design. Once you have guidelines, then you have requirements. And once the requirements are built into the full set of requirements, then it's part of the job. So then you have to have designers to actually do the job. It's a long-term effort, but gradually it gets in. But NASA is pretty much driven by requirements. If you go to the NASA procedure requirements website, you have thousands of requirements, and then if it's a requirement, we have to do it.
Yeah, that's a great answer. I think I'm curious. Maybe we can close off on a last question I saw in the chat about maybe each of you can also highlight this. What are some things on the horizon that you're really excited for human-centered design and agile methods in the space industry at large? What are some developments that you see on the horizon that you're excited about?
I think the involvement of industry and how industry approaches that is probably where you'll get the most fundamental change. And when you say industry, of course, right, and you say, well, uh, you know, when you say something is done by industry, all the big projects we've done have been done by industry, right? It's the contractual and relationship and the nature of that relationship. So if NASA says, okay, go build me a rocket and build it to this spec. That is different from NASA procuring a service where, in effect, NASA specifies an outcome. And it's still NASA money, but we say, okay, I want to land on the moon, and then we're going to specify what that looks like, or I'm going to get crew and cargo to the space station, right? I think that flexibility in contractual relationships provides industry with a tremendous amount of flexibility. And then, of course, there are the purely market-based companies out there doing things. And I think with that, and then, the next generation of people you have coming in, you will see people with design backgrounds and interdisciplinary backgrounds. And I think these things will happen naturally. And to me, it's that space is no longer just, I'll put that in air quotes, a few big contractors and the government. It's now much larger than that. And that to me is extremely exciting and a fundamental change.
And from my side, if you look at emerging technologies, you have robotics, you have autonomy, you have AI. All of these are not only technical disciplines, but they require design interactions. So therefore, having designers on the team are a must because it's not just a technical solution.
Yeah, you know what? I'm not disagreeing with anything he said, but that alone certainly won't get designers hired, right?
Yeah.
You're going to need a much broader awareness. And again, you know, an understanding of that system engineering process, as I've said repeatedly.
Mhm. Awesome. Thank you very much. I think I have not covered all the questions in the chat. So although it's getting accepted that space architects are necessary to be included in the design, and I'm guessing here specifically for human space habitats, what will it take to include them from the beginning?
Define what a space architect is.
That's a good question. I'm guessing someone with a design and architecture background being involved in the process of shaping your space habitats.
I would say if you're a space architect and you want to be involved, go get a job at one of these places. Speak the language of the stakeholders. Again, as Tibor said, right, these folks were initially hired as engineers, but they're doing design, right? Don't I think it's very difficult to go sell people on don't put it too much in their face is what I'm trying to say. Unless you have a very sympathetic stakeholder, and I think a lot of this stuff happens on an individual basis personally. That's the way I've seen it spread. I have not seen some big organizational aha. I've seen little examples where it sprouts in different places. I don't see why it would be any different for space architects.
There was one more quick question from Danica about cybernetics. If I can say a couple of words about cybernetics, because I mentioned it. Cybernetics is basically circularity, it's conversations, and it's controlling the system. So when you have this interaction, the circular interactions, you can broaden the paradigm, you can broaden your options, you can reduce the options, you control the system through these interactions, and eventually you reach to move towards a goal that you want to achieve. It's a very one sentence word, very top level.
And then the final one on my overview here is how have you kept yourself from being discouraged in the face of consistent lack of understanding? Well, maybe you can first answer, have you felt that you've met a lack of understanding consistently? And if so, how have you kept yourself from being discouraged in that?
Well, working for a space industry is an uphill battle. You spend your whole time writing proposals, you submit it, you get rejected, you kind of dust yourself off and try it again. The same thing with design, with all of these new things that you want to introduce, that you believe in your mission, you believe in your goals that you want to achieve, and just keep moving forward, and then hopefully one of these days it will be accepted. And step by step, it's getting more and more traction.
I never felt a consistent lack of understanding. It was highly variable, the degree of understanding, let's just say. But there were always enough people who were very supportive and very interested to make it work.
All right. Well, I think we've gotten to the end of our time here. I want to thank you so much for your insights and your comments. It's been super, super interesting to hear your thoughts on pioneering design at NASA. I'll hand it over back to Ola.
Thank you very much. It was super insightful. We had a lot of engagement as well from the community. So we really hope we can get this conversation going. So please join the WhatsApp group. We can, we can keep talking about this. Again, the recording will be available on YouTube. Thank you very much, everyone, for this fascinating conversations. And yeah, have a good evening, day ahead, wherever you're based. And yeah, let's keep it going.
Thank you very much.